So I thought I'd start off by going over the tools that I use. Now, this is the tool I use every day. This is Visual Studio. I happen to have the Pro version, but there's a free community edition that is very good, and basically it's not crippleware as well. I also mentioned this tool. This is Visual Studio Code, and I've got a project. I don't even know what it is, but this is a lightweight editor. It's almost like a text editor, but with a lot of cool features behind it. It loads fast and builds fast and all that stuff. Runs on Mac, Linux, and PC. This is SQL Server Management Studio. And okay, this is Sublime Text. And so when I want to use a text editor, I use Sublime Text. And there will be times that I will probably pull this open so you can do cool stuff like multi line select. Okay, so anyway, yeah. So you can move lines around with it. And so Sublime Text is an awesome app that I'll probably be using some. So I'm gonna, now I can start LinkPad. And in fact, I can pin that to the taskbar. There we go. All right, so LinkPad is an amazing tool for, the great thing about LinkPad is sometimes you want, oh, what's the syntax for that? Or what's a good way of writing that? So you can use LinkPad. You can type in an expression like, let me give you an example. You could like, hey there, oh wait, I have to do hello world, right? Not really, but. So in C# it normally uses, oh, look, it dumped itself. So it put twice. So in other words, when you're in expression mode, you can do that. Okay, interesting. You can also do statements. So I could do like var s equals. Now that you do have to use a semicolon. And same output. And then you can also create a program. And so this is great. So let's say I wanted to like, how do you do random? You do, you know, var r equals new random. And I say, maybe I know that part, but I'm not sure. Now here's the thing. I have a license for this, and it would actually show me with IntelliSense with the license enabled, but it's not. But I'm pretty sure that, let's see. So for example, and let's see what happens when I do that. Okay, it actually worked. Wow. Okay, so now let's do this. Let's put a dump. So there we go. And it's going to do a number between 1 and 5, which, believe it or not, that's what we're going to be doing with Dicey. Something like this. I have a lot to say about the random class that's in C#. But anyway, so that's LinkPad. It is great. It's fairly inexpensive, but there's a totally free version too. So you will want to get LinkPad again for just kind of toying with C# language features, reminding yourself the syntax, and so forth. So that's the tools. There might be more that I think of later, but for now that'll do. Those are the ones we'll be using the most in this show. And now let's go ahead and get started. So we're going to probably today maybe just create the project structure, and I'll show you how that works. And I haven't done anything on this really, so I've been kind of leaving it. So right now I've got no solution loaded, and I'm going to create a new solution. Okay, and I keep all my solutions in a folder in my documents, which I'll get to in a second. But what are we creating here? Well, the solution at this point doesn't really matter. I'm going to call this solution. I'm going to call it I have a little company now. I'm employed by a real, the man employs me. But I also do have a little side company called Spearsoft, and I do a little bit of consulting. So we'll call that this project Spearsoft. And why don't we call it, I was going to say Twitch, but no, let's not do that. I'll do Spearsoft games.dicey. Okay. And the location, I'm going to put this in projects, and I'm going to put it in a new folder called, oops. Okay, it does not exist. I thought that might happen. So let's double click slowly twice. Spearsoft.games.dicey. Okay, select folder. Okay, let's make sure that's right. Okay, so it's going to create a solution called Spearsoft.games.dicey. It's going to create a directory for the solution. It's going to use the newest .NET framework. I could use 4.7.1. Let's go with 4.6.1. And it's also going to create a Git repository. Okay, so what are we going to do? I'm actually creating an empty solution right now. All right, so here we are. We got our new overview screen. This might be new to the new version of Visual Studio. I updated it not long ago, but I'm gonna close that. You'll do most of your navigating right here in the Solution Explorer. It's probably the most important window, or at least sub window in Visual Studio. You can also get to it here. You Control WS, blah, blah, blah. I think more significantly, let's find out what Visual Studio did. So here we are, and it noticed that I created a folder. Now I could have created one and called it Spearsoft. I could have called the project and it would have created a folder for me called Spearsoft.games.dicey. And notice that it created its own folder, and here's a Git repository. And one thing I like about having Visual Studio create the Git repository is it will do stuff like create the git ignore for me. So it's a fairly complicated git ignore file, and I don't have to worry about grabbing it from somewhere. It excludes all the stuff you want excluded from source control management that is Visual Studio Microsoft oriented. So like I have, for example, ReSharper. Wow, ReSharper is not running. I got to figure that out. I've got ReSharper, and all the extensions for that are ignored. All your course build objects and so forth. I'm just going to, full disclosure, I'm not a Git expert. We don't use it at work. If we used it at work, I'd be an expert. It drives me a little nuts that we don't use it at work, but we don't. And I've tried to talk people into it, and they aren't buying it. So anyway, so this is the structure that got created. So we've got a solution folder, Spearsoft.games.dicey, and it created a solution file inside of it, and it created a project inside of it called Spearsoft.games.dicey. Now, it's interesting. It created it as a web project, and I'm not sure why. I don't remember selecting that, but maybe I did. Hey, normally I would not do this. So here's what I'm going to do. I'm going to actually take this. I don't know what's going to happen when I do this. I'm going to take this. So just back to this. Here is the solution. Here's the solution file, but there is also a project with the exact same name. And notice that in the Visual Studio, I've got the solution. I've got a project with the exact same name. Thank you. Okay, I'm going to remove that. So that leaves me with a quote empty solution. And so I am now going to, it's interesting. It's under Git control. So I think, okay, let me show you another tool I use. I use TortoiseGit. And I'm going to have TortoiseGit delete this. Do you really want to remove? Yes, I do. Okay, so it's just marked it as deleted. And so I guess this is as good a time as any to go over some of the Git stuff for Visual Studio. So Git is now a first-class citizen in Visual Studio. A little known fact is Windows. I mean, literally several terabyte source code for Microsoft Windows 10 is now being source controlled. I mean, source control is now in Git. That's a little a little known fact. At my work, we use Team Foundation Server, which I like. I just hate the source control. So anyway, now Microsoft doesn't even use Team Foundation Server for source control. For project management, it's great, and we will be actually looking at that when we do all this. But let me show you something. So another important Explorer window in Visual Studio is Team Explorer. And since I created a repository, I can go see what the changes are. And notice that it's marking some things as missing. Yeah, the solution is new. It's blah, blah, blah. So I'm going to commit this. Okay, I'm going to call this first commit. What does that mean, commit staged? Oh, yeah. Okay. So now I'm going to go back to here. I'm going to look at changes. Now, I don't get why this is not. Oh, maybe it's not saved. That's why. Let's save it. Save all. Yes, there we go. And second commit. This new solution. There we go. All right. So notice when I go here to Team Explorer and I go to changes, there are no pending changes. So we're all checked in. And if I go back to here, notice that it's still showing us. Now it's curious. Why? It could be the icon overlay is just broken. Well, let's see if Tortoise Git thinks that this needs to be committed. No files were changed. So that means this icon overlay with the red exclamation mark is wrong, and that just happens a lot in shell integrated Git and other source control systems. So anyway, we're good. So let's go back to Solution Explorer. Let's create a new project. We'll do a new project, and in this case, I'm going to type class library. And I want it to be C# class library. Okay, so now in Visual Studio, you have a lot of different options. In fact, you have to be careful because you can create a .NET Standard or core version of everything, or the traditional .NET framework. And I've said we're going to be doing the Visual Studio project as a .NET framework app. Now, if you want to know the difference, and I'm not a walking, talking expert, but the gist of it is this, that the .NET framework is a large framework that has to be installed on the target computer. .NET Standard and Core allows you to ship the framework assemblies that you need with your project, which is one very nice reason to use it instead of the framework. It should be completely compatible, so I should be able to take code I've written in the .NET framework and use it in a .NET Core project and vice versa. So since it's what I'm used to, we're going to use a class library that's Visual C# and it's .NET framework. Now here's what I'm going to call this. I'm going to call this spearsoft.games.dicey.gameengine. So in this case, I'm creating a projects class library, and it's going to have kind of a lot of the core gaming code in there. Okay, cool. Notice I now have a solution. I've got a new project, and notice, by the way, the plus and the plus, those show that these are now under source control. So let's switch back and see what happened. Notice that. Now it's interesting. Okay, I'm pretty sure this is, I thought I had deleted it, but maybe I didn't. So I'm about to find out because this is just not going to work. Okay, now I'm going to build this. So to build the project, You just built it. You can hit F5 to do that as well, but that will build and run. F6 will just build. So, okay, so it's not showing F6 keystrokes. I may need to work on that. But F6 also will build. All right, so let's step back. I've already shown you that there is a project called the Game Engine. And notice that for a C# project, when you create it, it creates a CSproj file. And that has all your metadata about this project. It also creates this class 1.cs, which we'll be deleting here shortly. Now, what is a project? A project is something that compiles to an assembly. You say, wow, that's fancy. Well, let's look at here. I just want to show you one thing. Notice I deleted the bin and the obj folders, and that's okay because they are build artifacts. And if you notice, if I rebuild it, they come right back. But you never want these to be under source control because they're build artifacts, and that's one thing that gitignore file here makes sure that it happens, that these don't get put into source. So let's look what a build, an assembly looks like. This is the GameEngine.dll. And one thing to know about Visual Studio projects is a project maps to an assembly. So every project creates an assembly. And you say, well, what's the PDB? I will tell you, you don't have to really worry about it, but I will say that you're going to find one of the amazing features of Visual Studio is that it's very good at debugging. And that stands for Program Debug File. And it's used by Visual Studio to help you debug. So you don't want to remove that, but the point is once this game is ready for distribution, you only distribute the DLL. You probably won't distribute the PDB. But the key point here is that the Game Engine has a file now with the same name, and that is an assembly. And it doesn't do anything yet, but it will compile. All right, so I'm going to delete this class file, and I'm going to be adding another class here in a minute. Anyway, so I'm going to create a couple more projects, and I'm going to create another project. Now, here's a project called, that's distracting, so I need to really figure that out. I'm going to create another project called Console. And you say, well, what is a console app? Well, let's look. All right, so I'm going to do a console app. This one's going to be Visual Studio, and I want to make sure I'm choosing this one because I want .NET Framework console app. And let's see if I'm forgetting anything. I'm not. Okay, now I'm going to show you a little trick. This, first of all, let me build it. And just to show you what's going on, going back to here, notice that the console app also created a bin folder, and it also did a build. Now, here's the thing. If you'll notice, this is an exe, and this means it can actually be run. It can be executed. Now, I'm not sure what'll happen because right now there's absolutely no code in this thing. It just opens and closes. I don't know if you noticed that real quickly. There's nothing to do. So a console app can actually be executed. One important point about the DLL, the library, this game engine, is it can't be executed. And to prove that, I'm going to show you. I'm going to go here, and if I right click, now I have two projects, and I can choose which one is my startup project. So if I do set a startup project, the game engine, and then I go up here, and instead of just building it, I actually build and run, which I can do with clicking there. I can also hit F5. Notice that I get this error. It says project with output type of class library cannot be started. And it can't. There's nothing to start. It's a class library, which again, we'll be learning more about what does that mean that it's a class library a little bit later. However, if I make this the startup project and run, it does run. Now it just quits because there's nothing to do in there. So what is a console app? A console app is a program that runs in a console window. So like, for example, you might say, oops, okay. For example, yeah, it's kind of a console. Basically, the command window that's built into Windows is kind of a console, right? And a program, a console app is one that you write. And I find that I frequently create these. You say, well, aren't we writing a game? Why do we need a console app? Well, this is going to be the first UI. And we'll learn a lot about string handling and so forth by using a console app as the first UI for our game. For now, just so that it will actually do something, notice that every console app starts with a void main. Well, anyway, that's what I was trying to do. And of course, you got to do hello world. Okay. And now it actually does something. There we go. Okay, so that is our console app. Now what else are we going to need? Again, the console will be our first front end. Game engine we'll talk about. I'm also going to put a unit test project in. So I'm going to do a new project. Now notice that if I type unit test, I can actually do a unit. Oh wait, I was about to say I have to do an MS Test unit test project. That's interesting. It just says unit test project. So I wonder what will happen if I do that unit test project. I wonder if I can actually choose the framework. Interesting. So in this case, because another an alternative is to actually, let's try it. So in this case, I'm going to call it spearsoft.games.dicey.tests. Wait, no. So in my case, I usually create a test project for specific other projects. So in this case, I've got a Spearsoft Games Dicey Game Engine. I've got Spearsoft Games Dicey Game Engine.test. So if I want to test something in the console, I probably won't, but if I did, I could create a .console.tests. So, and in this case, it's same framework, and let's make sure it's, oh, whoops, I'm glad I noticed that. We want a .C# project. One thing of interest, you can mix, at the project level, you can mix Visual Basic with C# projects. In fact, you can do F#, any other supported .NET language, because they all compile down to the same thing. But I do almost all my work and enjoy C# the most, although I want to learn F# one day, which is called a functional programming language that Microsoft offers. So anyway, I'm going to click on OK, and let's see what happens. It's creating a unit test project. And Microsoft Visual Studio Test Platform. So it might, what that might mean is that this unit test, yeah. So this unit test, I think this is going to use the, I'm pretty sure test method is an MS Test unit test, and I'm not a huge fan, and probably in another video I will probably switch that to NUnit, but this will work for now. So we're going to also learn the unit test. So what do you do with the unit test? You can do stuff like, well, normally you do, so with unit tests you want to do AAA, which means arrange, act, assert. Okay, so that's the kind of thing you do. So too bad, because I could show you what happens. ReSharper has a great test runner built into it. I could still run the test. It's going to fail because, oh, it says passed. Interesting. So I guess the default is that the test passes. So anyway, all this to say is when you write methods, so let's talk about why do you have unit tests? Hopefully what happens when you design an app is you end up with what are called use cases. And those use cases, basically, you need a way of testing them. And so as you code something, you're going to write unit tests to make sure that the functionality you're adding to, for in our example, the game engine, that it's working as expected. And there's this idea of code coverage, which means is a unit test covering every single code block in my code? And if the answer to that is yes, then you have complete or 100% code coverage. You should know I don't believe in that. There are a lot of people that do. And but to me, the trickier parts of your code probably should be unit tested. Now, that said, we may go for 100% code coverage with this project. I've already said I'm going to do stuff that, or at least in the description of this, I'll do stuff that may not make sense in real life. So anyway, we'll talk about that. So what you do is you write a class, you write a method, and the method is supposed to do X, Y, Z. So you write a test to make sure it does. There's also something called test-driven development, which basically, with test-driven development, you write your test before you write the method. And so you basically tell, hey, I want this to happen. And then you run the test, it fails because that doesn't even exist. And then you create that thing in your business object, in this case, the game engine. And now it exists, but probably still doesn't work. You keep working at it until you get it to actually run. The test method works. And then in test-driven development, the last thing you do is you actually refactor it. You clean it up. So we'll talk about refactoring. ReSharper has amazing refactoring tools built in. There's nothing to refactor there. I could grab that, and then I can refactor stuff. So that's unit test-driven development. I don't know if we'll do test-driven development or not, but we'll get a look at it. So those are 3 projects that we're going to add to our project. I'm going to do save all. I thought we would create one class and then we'll be a little over an hour, but I got started a little late, so that's okay. So that's a little bit on solutions and projects. And let me see. Seer, are you there? Do you have any questions? Okay. All right, so we're going to create one class in this game engine. So one thing that's true about all object-oriented programming languages like C# is that they can model real things. So in our case, what I would do, like let's say I had a customer said, hey, we want you to write an app for us and it's going to be called Dicey. And then they describe the game to me, and it turns out it's Yahtzee. So, and then I would go, oh, cool. So I would get the Yahtzee rules, but pretend like this wasn't the Yahtzee rules. Pretend that instead this is what I got when I left the customer. Because really I want this to be more about business apps. But it's, again, going to be a good problem to solve. So I would have this information, and then I would look for concepts that need to translate into my code. And so here we've got 5 dice, we've got a die, and we've got this sheet. We'll probably figure out a way to convert that into code. You have scores, and those scores have running tallies and so forth. And this is all the kind of stuff we want to do in our program. So today, I'm going to create one class, and I may end up, yeah, there we go. I may create 2, but let's at least create one. So we know that we're going to need a class in our game engine called die. Now, in this case, I'm creating a class in the keystroke. Alt-insert allows me to create a new file. I'm going to call it die. Okay. And in this case, the die class needs to model the real world. And fortunately for us, it's not very complicated. A die is 6-sided, and each side has a number on it, and at any given moment, it will have a value assigned to it. And in fact, the first thing I'm going to do is create a property, and this property is of type int, and I'm going to call it value. Now that may not be the best name for it, this value, only because it might be it might be a keyword that's used in other places, but I like it. We're going to go with it. So what is this? I've created a property, and a property is something that holds a value in a class. So in this case, it has a get and a set. So that means this class can be you can read the value and you can write the value. Now, you can also create classes that can only be gotten. Okay, and what is that saying there? Yeah, so in that, it's asking here, how does it get set? Well, it can get set in the constructor. You say, well, what is a constructor? A constructor is a special method in a class that sets up the class. It sets itself up. So in this case, I could do value equals 1. Okay, so, and now in real life, of course, the value is going to be randomly set. We'll get to that in a little bit, but notice that, and we can also do this, and it's just, instead of just having a getter, we can do private set. Same thing really, and in fact, ReSharper's telling me that that's redundant, but it's not redundant if I don't have this constructor. That means basically I'm going to set this somewhere else in the class. In my case, I want to set it here, and I'm going to also set it elsewhere. So I'm going to leave that. Let me see what that's saying. Yeah. All right. So what does a class have? It basically has two things. It has data and it has behavior. And so in this case, we got data, like this die is going to hold a value, and we happen to know that it's going to be between 1 and 6 at all times. We could actually write a unit test to make sure that create die and create 100 instances, make sure that they're all between 1 and 6. But we'll deal with that later. The other thing that a class can have, so it can have behavior, data and behavior, and data is represented by properties. This is property syntax, okay? And you can also have methods. So let me say one thing about properties. Watch this. I'm going to let ReSharper do this. I'm going to have it create a backing field. And okay, in this case, notice that when I did that, it created this line up here, and it created a setter for a getter for it. And in this case, let's do this. I want to show you this. I want to show you what it looks like if it's not private set, or if it has a getter and a setter. Okay, so I have this is called a private field, and notice this is a very common convention to take the same name as the property. Notice the property, this is called camel cased. No, it's not camel case. This is called Pascal case. So the first letter is capital. And it's very common in private fields that you start with an underscore and then you do lowercase for the first letter. So these kind of match up. Now, here's the thing. The getter is just returning whatever is in this property. That field, that private field. The setter is actually setting this private field to this. It's a hidden kind of invisible value that gets passed into the setter called value. It's kind of magic that there's this. And by the way, this is a good example of we have a keyword called value. Here's where it is. I don't think it minds that we're using that keyword. Let's see if it compiles. Yeah, okay, good. Now, this is, I can't remember which version of C#. This is how you had to write all your methods using a private field and this kind of getter setter. And the bottom line is that somewhere along the way, they changed the syntax so that you could do this. Notice that the field is gone, and now you have a getter and a setter. Now, that's called an auto property, and keep in mind it's just syntactic sugar for the same thing. Both those methods compile to the same thing when you look at the result of what you compile. So we're going to use these auto properties most of the time, but there might be reasons to use one with a backing field every once in a while. Okay, so that is an example of a property, and then you also have methods. So a method can have a return value, or it can have no return value. So you have public void, or like returns a value. In this case, we'll return a value. And now one thing that you do with the die is you roll it. Okay. And let's see what it doesn't like about that. Probably there's not all code paths return a value. So when you roll the die, then it's going to automatically create a value of between 1 and 6. So I could, by the way, I could do void here, and I could just set this dot value equal to some random number. One day I'll learn to type. In fact, here's what we'll do. We'll do var r equals new random. And I am going to seed this or put this value in. I'm going to do r next, and in my case I want it between 1 and 6. Okay. Okay, so this is how I roll the die. Now, by the way, another class we're going to create is called dice. So that's a collection of die. And it will also have a roll method, and guess what it'll do? The roll method of the dice class will just call the individual roll methods of the individual die classes. So this is an example of a very simple class. It'll get more complicated as we go along here, but this is an example of a class, and it has behavior in a method role. It has data in a property value. So let's create another class. This one's going to be called dice. Now, here's the thing. This is special in that we know that our dice class is going to have, it's basically a bunch of individual dies. In fact, we know that it has 5 die. And in fact, that's maybe a unit test. We could say, hey, when I instantiate the dice class, is there more or less than 5? That would fail that test. But if it's 5, it would pass. So in this case, the dice class has also properties and methods in it, or behavior and data. So, but here's the thing. We're already going to get right away into a concept that's very important in object-oriented programming called inheritance. So I am going to do something here in that I'm going to inherit a list of die. Now, we could have done this several ways. Let me show you. We could create a private field, or actually a property. We create a property called list die. Okay, and I could call it my dice. Okay, and that way we have a property that can be set to my dice, blah, blah, blah. And probably with this, I'd have a private field called dice and so forth. This would work, but we're not using inheritance when we do this. And the nice thing about inheritance is you get a lot of stuff for free. So let me show you what I mean by that. If I get rid of this, and I say I want this dice is going to inherit from the list of die. And there's a lot I'm not explaining here. I'll do a little bit in a minute, but so notice what I can do right away. But let's go ahead and just do it for now. So I'm going to create a public method, and in this case, it's going to return void, and I'm going to call it add to set. I'm going to get rid of all this. This will not be in the final. I'm going to do die. Okay. And I'm going to this dot add, and I'm going to add die. Okay. Now, the point I'm trying to make here is that this add method, you don't look at this, you look at this class. There is nowhere in this class a method called add. You say, where did it come from? Well, it came from the list die class. You say, well, what is list die? All right, so this class has embedded in it what's called a collection. There are a lot of different collection types built into .NET. List is one of them. It happens to be my favorite, but there's, there's linked lists. There are arrays, which is what used to use in older programming languages. You've got you've got dictionaries where you have name value pairs. So there's a lot of different collection types. And then in .NET 2, they created this concept of a generic. So before .NET 2, if you wanted a list of die, you had to go code all that all on your own. You had to create a list of die and create we were able to generate a lot of it, but the bottom line is you had to create a lot of code. With this, you don't. I'm telling it, hey, I have this thing called a list, and it is a list of what? A list of die. Now, in this case, that could be a list of strings. It could be a list of ints. It could be a list of anything. That's what a generic is. This is called a type. I believe it's a type parameter. And that you notice I'm putting it inside the greater than, less than symbols. And that is where you set a type parameter. And you're saying, hey, I want this list to have a collection not of strings or of ints, but of die. And that this dice class gets all of those for free because we are inheriting from the list of type dies. So I'm going to get rid of this. It's not a real thing. And so I'm just going to show you this. What other properties might I have? I can't think of any right now. So here's what we're going to do. We're going to create a method, though. We're going to create some behavior, and it's going to return void. And in this case, guess what? It's called a roll. And in this case, guess what it does? It goes for each. I thought it was just this and this. For dot die. I was right. So it is in this. Okay. So in this case, we'll do the die dot roll. Okay. All right. So what did we do here? So notice that this class can have a collection of die, and it's built into it. And if we want to roll all of the die, we can loop through each of the die that are in my built-in collection, and I can call the roll method of each individual die. And we got to do some work on this because sometimes we don't want, this roll method has got to be fancy enough to know, hey, I don't always want to roll, even if I call the method. So we'll talk about that more as we talk about Yahtzee and how the game works. Anyway, that's a little bit, that's it. That's all we're doing today. So what did we cover? We basically covered, importantly, how to set up your project, how to create solutions, and how to set up projects. We talked about different project types, and then we created a couple of classes. And of course, next time we'll spend more time on the actual game engine. Let's see. Let me know if you got questions. Let me look, make sure. Let's see what it's looking like. Okay, and there aren't any. So the other thing we talked about is Git a little bit and how the built-in Git. And so we're going to go to Team Explorer and go to Changes. And notice we've got all these new properties and new projects and so forth. And I'm going to call this first video check-in. Okay. Commit. Now, one thing we haven't done yet is sync this up to the cloud, which we will get to, but we won't do that today. And, oh yeah, the other thing we talked about is we did talk about some of this file structure and solutions and all that. So hopefully you enjoyed this, and let me know if you got any questions. And I'm going to hang up now.